Welcome to another lecture on gate class. So we have a problem related to we will find out the problems related to system function, and we will find out the Laplace transform, and we can find out the impulse response of the system using the Laplace transform. So let us do some problems related to that. So let us do one problem. The problem is the output yt of a continuous time LTI system of a continuous time LTI system is found to be 2 e raised to the power minus 3t into ut when the input is xt, and the input xt is equals to ut. It is given that input xt is equals to ut. So the question is, find out the output yt, find out the output yt when the input xt is e raised to the power minus t into ut. So let us solve this problem. And also we have a part b. Part b is find out the impulse response. So what is part a? So part a is to find out. So part a is given. That find out the output yt when the input of xt is e raised to the power minus t into ut, and part b is find out the impulse response of the system. So let us solve this problem. So basically part b we have to solve first. First we will find out the impulse response of the system. So how to get the impulse response of the system? So xt is provided, xt is ut, and output yt is given as, when the input is ut, the output yt is given as 2 e raised to the power minus 3t into ut. So basically we have system, that is xt, and the impulse response is ht, and the output is yt. So if we find out the Laplace transform of this, then it is equals to xs, it is equals to hs, and it is equals to ys. So these are the Laplace transform. So what we will get here? We will get ys is equals to xs multiplied by hs. We have ys is equals to xs multiplied by hs. So we have xt is equals to ut, then xs is 1 by s, and the ROC is real part of s greater than 0. Please check this. Then we have ht is given as 2 e raised to the power minus 3t into ut. Then hs is nothing but 2 divided by s plus 3, and the ROC is given as real part of s is greater than minus 3. The ROC is given as real part of s greater than -3. Then ys is written as xs multiplied by hs, and that is equals to 1 by s multiplied by 2 divided by s plus 3. So it is equals to 2 divided by s plus 3. This is ys. This is ys. Now now we can find out this is yt, sorry, this is yt. So this is yt. So this is yt. Again this is ys. Okay, so we have ys is equal to xx into hs. So we have ys is equal to xs into hs. I forget that it is output. I had taken it as a impulse response, so sorry for that. So we have ys. So what is hs? What is hs? So hs is ys divided by xs. hs is nothing but the ys divided by xs. And what is ys? Ys is 2 divided by s plus 3. And what is xs? It is 1 divided by s. So s will go out, go at that numerator. So it is 2s divided by s plus 3. Now this is hs. So hs, what is hs? So we have impulse response ht, and the Laplace transform of this impulse response ht is hs, and hs is written as, hs is given as 2s divided by s plus 3. Now we can see that both the highest power of numerator and denominator is 1 only, so we need to perform the division. So it is s plus 3 into 2s, so we can multiply by 2, so it is 2s plus 6, then it will cancel out. So hs is written as 2 minus 6 divided by s plus 3. hs is written as 2 minus 6 divided by s plus 3. Now if we find out the inverse Laplace transform, then ht, that is impulse response, is given. So the part B is to find out the impulse response. So the impulse response of the system is 2 del t minus 6 e raised to the power minus 3t into ut. Please check this. So it is the impulse response of the system. So it is impulse response of the system. So this is basically we find out the part B of that our program, our question problem. So the impulse response is 2 del t minus 6 e raised to the power minus 3t into ut. This is our impulse response, because it is given that the ROC we find out is real part of s. Here real part of s is greater than -3. So since we can see that it is a real part of s greater than -3, so it is right sided signal. It is right sided. That's why I have written it in this form. That's why we have written in this form, in the form of ut, because it is a right-sided signal. Now let us solve the part A. So what is part A? Now we have we find out the value of hs by using that partial fraction, by using that ys divided by hs is nothing but ys divided by xs. So we find out in that part A, and the ROC is real part of s greater than -3. Now in the question the question is given that the input is now the input is no longer ut. The input now the new input is e raised to the power minus t into ut, and it will pass through that LTI system with impulse response ht. Now we need to find out the new output yt. We need to find out the response yt. So yt is written as, so it is xt. So it is written as xt convolution with ht. Now if we find out the Laplace transform, then it is equals to ys is equals to xs multiplied by hs. Now xs is nothing but 1 divided by s plus 1. Please check. And hs we find out it is equals to 2s divided by s plus 3. So ultimately ys we are getting is 2s divided by s plus 1 s plus 3. This is our ys. Now we need to find out the solution of this. We need to find out solution of this. So what is the solution we are getting here? We need to perform the partial fraction analysis. So how to perform the partial fraction analysis? I already told you. So we have ys, and ys is equals to 2s divided by s plus 1 s plus 3, and that is equals to a divided by s plus 1 plus b divided by s plus 3. So how to get the a? So a is s plus 1 multiplied by ys at s is equals to minus 1. So it is equals to 2s divided by s plus 3 at s is equals to minus 1, and it is equals to 2 into minus 1 divided by 3 minus 1. So it is equals to minus 2 divided by 2, and it is equals to minus 1. So a we are getting is minus 1. So a is equals to minus 1. Now what is b? So b is s plus 3 multiplied by ys at s is equals to minus 3, and it is equals to 2s divided by s plus 1 at s equals to minus 3, and it is equals to minus 6 divided by minus 2, and it is equals to 3. So b we are getting 3, b we are getting as 3. So a is equals to minus 1, we are getting a is equals to minus 1, and b is equals to 3. Now what we need to find out, that ys is equals to a minus 1 divided by s plus 1 plus 3 divided by s plus 3. Now we need to find out the yt. So how to get the yt? So yt is nothing but minus e raised to the power minus t minus plus 3 e raised to the power minus 3t into ut. So this is yt. So yt is minus e raised to the power minus t plus 3 e raised to the power minus 3t into ut. So this is our response. So let me summarize this question what we did. So initially we have input xt, and in impulse response is st, and the output is yt. So initially the input is ut and the output is yt. So basically that input is given, input is given, and yt is given, and yt is yt is given as 2 e raised to the power minus 3t into ut. Now so what we can do, we can find out the ht. That is impulse response of the system. So we can find out ht, that is impulse response of the system. So what is happening, that the impulse response fully characterize the system. If we know the impulse response, then we can find out the characteristics of the system, and impulse response is unique for any system. Please understand that impulse response is unique. So if we find out the impulse response will not change. So in that case we find out the impulse response. And also there is a shortcut method. So what is the shortcut method? That if we are applying a step as input, then the output we are getting is called the step response. So the step response is already provided to us, that is step response is 2 e raised to the power minus 3t into ut. Then what is impulse response? So impulse response is directly differentiation of step response will gives us impulse response, and it is nothing but 2 e raised to the power minus 3t. What is differentiation of ut? Differentiation of ut is del t, then 2 ut, and what is differentiation of e raised to the power minus 3t? It is e raised to the power minus 3t into minus 3. So finally ht we will get as 2 e raised to the power, and also we can apply sampling property here. So what we will get here, we will get here 2 del t, by applying the sampling property here. What we will get here, 2 del t minus 6 e raised to the power minus 3t into ut. So this is our ht. And please check that this is the same st. We get in by using the without using that shortcut method. So this is the shortcut method. Basically the step response is given and the impulse response is just the differentiation of step response. So this is our impulse response. Now in second part, what we have system. Now we know the characteristics of system because we know the ht. So ht is given. Now the input has changed. So previously the input xt is equals to ut. Now the input we have changed to e raised to the power minus t into ut. Now this is our new input. Now what is our task? Our task is to find out the value of output yt. So again yt is nothing but it is equals to xt convolution with ht. So basically this ht is given, so it is given, and this is also given. So ys is nothing but the multiplication of xs with hs. So in that case we have the both causal signal we have. So ys is xs into hs. So we find out that ys and the inverse Laplace transform of ys is nothing but yt. So in that sense we find out the yt, that is inverse Laplace transform of ys, that is inverse Laplace transform of ys. So we find out the value of ys, and this is basically the inverse Laplace yt, and this is basically the inverse Laplace transform of ys. Now let us do another problem. So the problem is related to causal BIBO stability. So let us do that problem. So problem is, if a continuous time LTI system, LTI system is BIBO stable, if continuous time LTI system is BIBO stable, then show that the reason of convergence of system function, HS must contain the imaginary axis, must contain the imaginary axis, must contain the imaginary axis, that is S is equal to j omega, that is our imaginary axis. So for the continuous time system, let us solve this problem. For the continuous time system to be bounded input, bounded output is stable. So for the continuous time system, for the continuous time LTI system to be bounded input, bounded output is stable. The impulse response should be absolutely integrable. The impulse response should be absolutely integrable, that is minus infinity to plus infinity modulus of h tau d tau should be less than infinity. So that Hs is given, the impulse response, the Laplace transform of impulse response is given, that is minus infinity to plus infinity ht e raised to the power minus st into dt. So let s is equals to j omega, then we can write it as modulus of h j omega is equals to modulus of minus infinity to plus infinity ht e raised to the power minus j omega t into dt, and that is equals to less than or equal to minus infinity to plus infinity modulus of ht e raised to the power minus j omega t into dt, and that is equals to minus infinity to plus infinity modulus of ht dt, and that is less than infinity. So this condition we met. So basically we already assumed that if the system is BIBO stable, then the impulse response should be absolutely integrable. So this condition, if this condition is true, so if we meet this condition, then we can say that then we can achieve BIBO stability, then in that case we can achieve the BIBO stability. So let us do another problem related to system interconnection. So we have a system, we have a LTI system, and there are two impulse responses, H1T, and second impulse response is S2T, and these two impulse responses H1T and S2T are connected in parallel. So H1T is given, and H1T is equals to e raised to the power minus 2t into ut, and H2T is given, and H2T is equals to 2 e raised to the power minus t into ut. So H1T and H2T is given. Now our question is find HT, and the part B is discuss the bounded input bounded output stability. Discuss the bounded input bounded output stability. So these two problems we are going to discuss these two problems. Uh, what we can do it, we can replace it with single impulse response, that is overall impulse response HT of the system. So what is HT? So in our previous lectures we have seen that when two systems with impulse response H1 and H2, and when they are connected in cascade, then the overall impulse response is nothing but the convolution of H1T with H2T. The convolution of H1T with H2T. So what we will receive? Let us take the Laplace transform. So Laplace transform of xt, the Laplace transform is xs. Then we have Laplace transform of y1t is h1s, h1t is s1s, and Laplace transform of h2t is h2s. So what is Laplace transform of ht? Is the Laplace transform of ht, that is Laplace transform of overall impulse response. It is equals to hs, and hs is equals to h1s multiplied by h2s. Why it is coming? Because as we already know that the ht is equals to h1t convolution with h2t. So there is convolution. So this convolution is saying that it is a convolution in time domain. So the convolution in time domain is equals to multiplication in s domain. So we have convolution in time domain, and h1t convolution with h2t, and it is nothing but the multiplication in s domain. So what is h1t? h1t is e raised to the power minus 2t into ut. So h1s is equals to 1 divided by s plus 2, and we have h2t is equals to 2 e raised to the power minus t into ut. So h2s is equals to 2 divided by s plus 1. So what is h1s? It is 1 divided by s plus 2 multiplied by h2s, that is 2 divided by s plus 1. So it is equals to 2 divided by s plus 1 s plus 2. So this is our impulse, this is our transfer function. This is our overall transfer function of the system. This hs is the or. So h2s is 2 divided by s plus 1. Now we can use this. Basically h1s is 1 divided by s plus 2, and h2s is 2 divided by s plus 1. So it is 2 divided by s plus 1 into s plus 2. So the hs is written as, 2 divided by s plus 1 s plus 2 is equals to lambda 1 divided by s plus 1 plus lambda 2 divided by s plus 2. It is written in this manner. So what is lambda 1? So lambda 1 is s plus 1 multiplied by hs. Hs is equals to minus 1. So it is equals to s plus 1 multiplied by 2 s plus 1 s plus 2, hs equals to minus 1. So it is equals to 2 divided by minus 1 plus 2. So it is equals to 2. So lambda 1 is equals to 2, and lambda 2 is equals to 2s plus 2 multiplied by hs. Hs is equals to minus 2. So it is s plus 2 multiplied by 2 divided by s plus 1 s plus 2. Hs is equals to minus 2. So it is equals to 2 divided by minus 2 plus 1. So it is equals to minus 2. So lambda 2 is equals to minus 2. So what is hs? So hs is written as 2 divided by s plus 1 minus 2 divided by s plus 2, and the real part of this is real part of s is greater than minus 1. It is a real part of s is greater than minus 1 because both signals are causal signals. Please understand that both signals are causal signals. So we have pole at minus 1 and also we have pole at minus 2. So in order for the system to be right sided, the real part of s, the region of convergence, should be greater than minus 1. So this is the region of convergence because we both signals are right sided signals. So the real part, so basically both signals, so both h1t and h2t is right sided. So the ROC should be right to the rightmost pole, should be right to the rightmost pole. So the poles are s is equals to minus 1, s is equal to minus 2. So rightmost pole is minus 1. So ROC is real part of s greater than minus 1. So the ROC is real part of s greater than minus 1. Now we can see that the impulse response, ht. So the impulse response ht is equals to 2 e raised to the power minus t minus e raised to the power minus 2t into ut. Please check, this is the impulse response. Please check, this is the impulse response. Now this is impulse response. So in part B we can find out the BIBO stability. So for BIBO stability, minus infinity to plus infinity modulus of h tau d tau should be less than infinity. It means it should be integrable. So let us check whether it is integrable or not. For BIBO stability, let us check whether it is integrable or not. So it is minus infinity to plus infinity modulus of 2 e raised to the power So for BIBO stability, just it is we can write it as e raised to the power minus 2 bracket start e raised to the power minus tau minus e raised to the power minus 2 tau u tau d tau, and it is equals to 0 to infinity. Basically this value is 1 is equals to 1 when we have 0 to infinity, when just tau is between 0 to infinity. So it is 0 to infinity 2 e raised to the power minus tau minus 2 e raised to the power minus tau minus e raised to the power minus 2 tau d tau, and it is equals to twice 0 to infinity e raised to the power minus tau d tau minus tau 0 to infinity e raised to the power minus 2 tau d tau, and it is equals to 2 e raised to the power minus tau into divided by minus 1. It is 0 to infinity minus 2 e raised to the power minus 2 tau divided by minus 2 0 to infinity. So finally what we will get, some bounded value. So what we will get here, so h tau, if we solve this, then we will find out that minus infinity to plus infinity modulus of h tau d tau is less than infinity. Please check, is less than infinity. It means since let us check. So since minus infinity to plus infinity modulus of h tau d tau is less than infinity, so it is BIBO stable system. It is BIBO stable system. Also we can alternatively we can see that ROC includes the j omega axis, so it is BIBO stable system. So that ROC, if we just plot the ROC, then we have pole at -1. There is another pole at the pole at -1, and there is another pole at -2, and the ROC is this ROC is real part of s greater than -1. So we can say that the ROC includes the j omega axis. The ROC includes the j omega axis. So system is bounded input, bounded output stable. So the system is bounded input, bounded output stable. The system is bounded output, bounded input stable because the ROC includes the j omega axis. Because the ROC includes the j omega axis. So let us do another problem. Let us do another problem. So the problem is using the Laplace transform. Using the Laplace transform. Using the Laplace transform. The system using the Laplace transform, the system is described by described by dyt divided by dt plus ayt is equals to xt. Now we need to find out the impulse response ht. Find the impulse response ht of the system. So in order to solve this type of problems, we can use that method that is adopted in case of continuous time LTI system, but by using Laplace transform we can easily find out the impulse response. So how to solve this problem? Please see that we have dyt plus dt is equals to a plus ayt is equals to x3. Now taking Laplace transform on both sides, taking Laplace transform on both sides, what we will get? So we will get sys plus ays is equals to xs. So we can take ys common, so it is s plus a is equals to xs. And what is transfer function? So the transfer function of the system, if you remember, this is input xs, the transfer function is hs, and the output is ys. So ys is hs multiplied by xs. So hs is nothing but ys divided by xs. So it is ys divided by xs. And what is ys divided by xs? It is 1 divided by s plus a. So the HT, that is impulse response, it is equal to minus AT into UT, because we consider the system that is right sided system. We consider the right sided system because the impulse response, we are considering that it is right sided system. So the impulse response is basically, it is right sided signal. It is right sided signal. If nothing is given, then please consider the signal as right sided signal. So that ROC is given if for A, suppose A is greater than 0, then it is the ROC is real part of S is greater than minus A. So if A is greater than 0, then minus A is somewhere at this, so it is the ROC. It is the ROC. This is sigma and this is j omega. This is the ROC. Okay, so in this manner we can solve problems like this, and let us do another problem. Let us do another problem related to differential, related to differential equation. So it is find ST of system. Find ST of system. The system is described as y dash t is equals y dash t plus 2 times yt is equals to xt plus x dash t is equals to xt plus x dash t. So the solution is, again taking the Laplace transform on both sides. So taking Laplace transform on both sides, first we will get sys plus 2 into ys is equals to xs plus x into xs. So taking the common, so it is s plus 2 is equals to xs. Taking the common, it is 1 plus s. So the transfer function is hs, that is equals to ys divided by xs, and that is equals to s plus 1 divided by s plus 2. Now we can see that we can find out the division. We can find out the division. So just we multiply it with 1, then we will get s plus 2. So it is minus 1. So it is nothing but 1 minus 1 divided by s plus 2. So the impulse response is del t minus e raised to the power minus 2t into ut. So this is the impulse response. This is the impulse response, that is ht is equals to del t minus e raised to the power minus 2t into ut. This is the impulse response of the system. This is the impulse response. So let us do another problem. So the problem is the feedback interconnection. The feedback interconnection. The feedback interconnection of two causal signal of two causal systems of two causal systems with system function Fs and Hs is given as xt. The system is given as, it is summation symbol, summer. Then we have this is suppose this is RT, and we have GS, and then we have ET, this is ET, and this is FS, and this is our YT. This is our YT. Now a part of YT is fed back to GS. A part of YT is fed back to GS. So let us find out. So what we need to find out? Find out the impulse response of the system. Find out impulse response of the system. Find out impulse response of the system. So let us solve this problem. So that Ys is written as, if we see that if we find out the Laplace transform of Yt, that is Ys. So Ys, if you see that Ys is here we have Ys. So Ys is written as Es multiplied by Fs. So Ys is written as Fs multiplied by Es. So Ys is written as Fs multiplied by Es. And if we observe that, okay, so what is Es? So the Laplace transform of Et is Es, and Laplace transform of Rt is Rs. So what is Es? So Es is equals to Xs plus Rs. So Es is equals to Xs plus Rs. And what is Ys? Ys is Fs multiplied by Es. Ys is Fs multiplied by Es. So so we can use the value of Es. We can use the value. So let us write in next slide. It is better to write in next slide. So we have Es, and Es is equals to Xs plus Rs. Es is equals to Xs plus Rx, and Ys is equals to Es into Fs. So this is equation number 1 and this is equation number 2. So using 1 into 2, what we will get? We will get Ys is equals to Xs plus Rs multiplied by Fs. So it is equals to Xs into Fs plus Rs into Fs, and it is equals to Ys. Now we can use the value of Rs. So what is Rs? So Rs is so if we see that what is the value of Rs, if we see the previous slide, then we can find out that Rs, here this is Rs, it is nothing but multiplication of Gs with Ys. So Rs, we can write Rs as, so here Rs is nothing but Gs multiplied by Ys. This is Rs. So we can use this value. Okay. So Rs is equals to Ys multiplied by Gs. So Rs is equals to Ys multiplied by Gs. So we can use that value. So we can use Rs. So this is equation number 3 and this is equation number 4. So using 4 into 1 we obtain ys is equals to fs into xs plus fs into ys into gs. So please check this relation. Now what is the that we can take common, what are the terms we can take common? So we can put ys term in this side. So what we will get, so we will finally get ys is equals to what we will get, ys divided by xs, that is hs, that is transfer function, is equals to ys divided by xs, and it is equals to fs divided by 1 minus fs into gs. So we can solve this in this slide itself. So we have, if we see that here, we can put ys term on the right hand side. So we can say that ys minus ys into fs into gs is equals to fs into xs. So we can take ys common, so it is 1 minus fs into gs is equals to fs into xs. So this is the thing we have written, here. So we have transfer function. hs is the system transfer function. So hs is nothing but the system transfer function. And hs is equals to fs divided by 1 minus fs into gs. So this is our transfer function of the overall system. The transfer function of the overall system. Now let us discuss the initial value theorem. Let us discuss the initial value theorem. So what is initial value theorem? According to initial value theorem, if we find out the initial value, that is x0 plus, so it is equals to limit s tends to infinity as into xs. So what is xs? xs is basically the Laplace transform of xt. So let us prove this. Let us prove the initial value theorem. So before the proof of initial value theorem, let us discuss the property of differentiation in time domain. Differentiation, because we are going to use this property for finding out the initial value. So the property is differentiation in time domain. So what is that property? So according to this property, if we differentiate the time continuous time signal dxt divided by dt, and if we find out the Laplace transform, then what we will get? We will get xs minus x0 minus. So we will get x as minus x0 minus. So this is called differentiation in time domain. This property is called differentiation in time domain, but this property is true but when we have provided this condition, when we have provided that limit t tends to infinity xt e raised to the power minus st should be equals to 0. It means if this property is not, it means that integral should be summable. Means what is that xs? Xs is minus infinity to plus infinity xt e raised to the power minus xt into dt. So what is the catch is that this integral should be integrable. This integral should be integrable. So this integral, so it should be integrable. So this condition, if this condition is not satisfied, then we are not able to find out then we are not able to write dxt divided by dt is equals the Laplace transform of this is sxs minus x0 minus. In order to get this relation, we have to provide this condition. This is the necessary condition for this relation, for this differentiation relation. Now for general nth order derivative, so basically the repeated so basically the repeated application of this property, repeated application of this property yields d square xt divided by dt square. The Laplace transform is s square into xs minus x0 minus x dash 0 minus, and if we find out the nth order derivative dn xt divided by dt n, then it is equals to s raised to the power n into xs minus s raised to the power n minus 1 into x0 minus s raised to the power n minus 2 x dash 0 minus dot minus x n minus 1, that is n minus 1 derivative 0 minus. So ex 0 minus. Okay, so basically this is n minus 1 derivative. So this is our repeated this relation we get when we have repeated differentiation. So in general where x r, the rth derivative 0 minus is equals to dr divided by dxt, dr divided this is xt, sorry, so dr xt divided by dt at r is equals to 0 minus. So so basically here we have x0 minus means dx divided by dt at t. So x0 minus is nothing but dx divided by dt, dxt divided by dt for t is equals to 0 minus. Like we find out the rth derivative, then rth derivative of this is at 0 minus is dr dxt divided by dt, and r is equals to 0 minus. So this is a differentiation property. Now we are going to use this differentiation property to find out the initial value. So according to this differentiation property, we have xs minus x0 minus, and that is nothing but if we find out the integration from 0 minus to infinity dxt by dt e raised to the power minus st into dt. So this is the differentiation property. So basically what is the differentiation property? dxt by dt, the Laplace transform is nothing but xs minus x0 minus. So just we have using the definition of Laplace transform. So this is the definition of Laplace transform. Now what we can find out that we can just write this integral from 0 minus to 0 plus dxt divided by dt e raised to the power minus st into dt plus 0 plus to infinity dxt divided by dt e raised to the power minus st into dt. Now we can write it as finally we can find out that we have x0 plus minus x0 minus. So it is written as this integral, it is written as x0 plus minus x0 minus plus we have 0 plus to infinity dxt divided by dt e raised to the power minus st into dt. So basically in this case what is happening that the differentiation and integration will remove there. So basically we will get only xt at the lower limit is 0 minus and upper limit is 0 plus. So what we will get here, it is xs minus s0 minus. So this x0 minus will cancel out. So what we will get xs is equals to x0 plus 0 plus to infinity dxt by dt e raised to the power minus st into dt. Now what we will get finally is limit. What we will get finally is xs is equals to x0 plus 0 plus to infinity dxt by dt is equals to multiplied by e raised to the power minus st into dt. Now if we apply the limit on both sides, so limit x tends to infinity, xs is nothing but it is equals to limit x tends to infinity x0 plus 0 plus to infinity dxt by dt limit s tends to infinity e raised to the power minus st into dt. Now when we apply the limit s tends to infinity, this term it will become 0. So this whole integral will become 0. So what we will get, limit s tends to infinity sxs is equals to x0 plus. So this is called because this is a 0, so we have this term remaining. So this is our we have this term remaining. So what is that? Uh, what is that? This is called the initial value. This x0 plus is called the initial value. Hence proved. Hence proved. So this is called the initial value theorem. So we have proved the initial value theorem.